Hello there, all you gophers. I wanted to talk a little bit about using Go on Lambda in order to build skills for Alexa. Something that I wanted to play around with, and I spent the afternoon kind of getting it going. So, didn't see anything on YouTube. Thought it might be fun to show you how it works. First, just to get you started with Alexa, if you have an Echo, or in my case, an Echo Dot, uh, you should be good to go. Log into developer.amazon.com/alexa/console, and you should be able to sign up for a developer account for Amazon. If you already have an Amazon account, it looks like you just pass right through, so it shouldn't be any problem for anybody. And once you're there, you can start developing skills. And the way you start by developing skills is to click Create Skill. When you want to develop a skill, you're just going to give it a name. It can be sort of whatever you want. You're generally going to start with a custom. And once you get here, you're ready to go. There's some helpful videos that were actually pretty good. But let me give you a quick run through of what it looks like if you haven't done it before. The first thing is the invocation. The invocation name is the thing you will ask Alexa to access. So you will say, Alexa, ask my app to something. So the ask whatever is the invocation name. So you set the invocation name. And then the thing that comes after the invocation is the actual commands, if you will, that you're going to send to your skill. And these are intents. By default, all apps have to have 3 intents provided: stop, cancel, and help. So if you say, Alexa, ask test app for help, it will trigger the help intent. Each intent will have utterances associated with it. Those utterances are the things that you say. So for help, the obvious thing is going to be help, or can you help me, right? All these things are going to be things that you would say, that you would utter, that are going to be sent to your app. So you define those utterances, and those associate with the intents. You can then add your own custom intents. They can be named whatever you want, but they should be descriptive. These are going to be passed to your program. So if, in my case, I'm working with a temperature probe, so the utterance might be, how warm is it? It might also be, what is the temperature? So on and so forth, right? You add all those that you want to, and so you have these 3 things that come together: the invocation, what you ask for, and then the actual commands that you build into the utterances, into the intents. In a nutshell, that's pretty much it. Like, once you've done that, you save your model, and then you click Build Model, and it will actually build it into basically a giant JSON blob that defines your app as far as Alexa is concerned. The thing that you have to add to this is an endpoint. The endpoint is going to be the actual code that processes the intents. So what you're going to do here is usually use AWS Lambda ARNs. So you'll then go to Lambda, and you'll create your function, which is going to be a Golang per this. And once you've created it, you'll take the ARN here, and you'll just paste it in here. Now, I'm doing this in West 2, and there are different fields for different areas. It doesn't seem to matter. The default region, I would imagine, would be East, but I'm using West 2, and it worked just fine. So once you've done that, you save your endpoints. you build your model, and then you can actually test it. So that's basically how you get going. So I'm going to leave this, and I will show you when you want to be in the new console. And so let's go ahead and look at, there's a skill ID. You'll need that in a minute. If you go and edit, you can see the skill that I was working on. And so I've got office temp as an intent with a whole bunch of different possible utterances, and hello, just sort of as a test. And you can see the endpoint that I have is to my Lambda function. Okay, so that's the Alexa side. Once you've done and build that, you actually then have access to this next tab, which is test. And here, this is really cool. You don't need an Amazon Echo at all. You can actually test it right here. So if I go ahead and test this, ask the office what the temperature is.
The current temperature is 68 degrees.
All right. So this is how it's sort of working behind the scenes. So there's an input JSON, which is actually sent to your application, the Lambda application. And there's a whole bunch of stuff here, but the thing that you're actually interested in is this request of type intent request, and then it specifies the intent name, which was office temp. That is the thing that you actually want in your application in the simplest possible case, because it will then let you decide like what you want to do. And you can see here the JSON that my Lambda responded with, which is response output speech, which of a plain text type, and the text to actually say was the current temperature is 68 degrees. So you can test and iterate. It's really cool. So in Lambda, you just have to attach a Lambda skills kit, which is just one of these triggers on the side here. And when you specify that, you'll specify the skills ID. That's all you need to know, which you got from the portal, right? And attach it to your skill. And then your skill, you just upload your zipped file and the handler, and you're good to go. So the code itself. So I started developing this with a simple Lambda Go prototyper that I created. This is the simplest possible Lambda in Golang, and what this does is it actually creates a interface, kind of an empty interface on a type, so that I can play around with the JSON that it passes in regardless of what it sends. And this prototype code I have here, actually, you can see it just prints out the raw events, and then it uses a type assertion to actually change from a sort of interface type map into a map that I can actually use via index because it's now got a string, and then it ranges over that. So this is a little code that I wrote just to sort of play around with and look at the input and investigate a little bit more. And then that evolved into my actual Alexa Go prototype, which is on GitHub. And if you look at the code here, it's a little more involved, but the thing that's magical here with Lambda in general, it's not specific to anything with Alexa, but that's kind of magical here, is we have a request handler that we pass to Lambda start. And here's my request handler, and you pass up to 2 arguments to it. The first argument is always going to be the context, and the second request argument that you're going to pass is the Alexa request. And here's the magical bit for Go programmers. It's JSON that's sent into your Lambda via whatever event sent it. And obviously in Go, like, the pain is that the first thing you got to do with this input is unmarshal it. Well, they wrap that into the library itself, so it unmarshals sort of by default. Therefore, you can see my prototype, because it unmarshals it by default. If I don't have something that handles the marshal, the unmarshal, then you just sort of are stuck. Which is why an empty interface is a way to just blob it into something. But the way you really want to do this is actually define a type that it's going to unmarshal into. So It's going to unmarshal it into Alexa request, and so none of this uses a library. This is all just sort of custom, right? So I created a structure called Alexa request, and I basically mock out the relevant portions of the requests that are being sent as input. So looking kind of through this, a lot of it I don't need, and you'll know that when you marshal JSON into a Golang struct, you don't have to specify everything. It will just drop anything that doesn't match the structure that it's marshaling into. So I only have the relevant portions here, which is version, request, and that's got a nested structure for the request, and that itself has a nested structure for intent, which is the thing I actually care about, so that I can figure out what it is that Alexa wants me to do. So just by specifying that structure, it will unmarshal into that structure, and I'm pretty much good to go. Now, just for debugging purposes, I use the very excellent Go Spew library to dump it. That ends up in a CloudWatch log that I can go look at and debug if something's going weird. I also print to the log the request intent name, so I know that it was supposed to do. And then I have a little function that just sort of initializes as a constructor a response. The response is pretty much the inverse. So I created the relevant looking JSON response structure with only the relevant portions again, so that I can marshal the response back in. So when I return, I can actually just return a structure, or in this case a pointer to a structure, and the library again will marshal the structure into JSON and return it. So the beautiful thing about Lambda here for Golang programmers is that you don't have to like marshal, unmarshal everything sort of explicitly. It all sort of happens behind the scenes. You just have to know that it's happening so that you can write your code to sort of do the right thing. So the response has to include version, has to here include response, and the output speech structure needs to include the type of response you're going to send and the actual text. So the text right there is the magic, right? So as far as all the data that's coming in, I really only care about two pieces of data. Coming in, I need to know what the intent was. On the output, I need to know what the text to send back is. That's it. Everything else is just sort of wrapper around it. So I create my little constructor to create this, just to simplify creating the structure with some of the boilerplate, right? In my case, I'm not doing anything complex. I'm not handling sessions. All I want to do is just sort of see an intent and then send back a response. So the version is always going to be version 1. The output speech type is always going to be plain text for my use. And I just kind of preset a default for text, which is, please override the default output. And then I return a reference to that. So once I've gotten my response back, then it's just a matter of matching up the intent to what I actually want to say. So I use a little switch statement, and so if I ask for the office temperature, it says the current temperature is 68 degrees. If I ask if the intent is hello, it will say hello, Lambda's working. And then you also want to include handling of the default intents that you have to include. In this case, I've only included help, since nobody's going to ask to stop or cancel, given the fact that I'm not doing sessions. So there's a little help output, and I've got a little default just in case something's not handled as I'm developing. Once you've got that structure, all your object, right, all sort of set up, all you got to do is pass a pointer, return a pointer to that structure. Oh, it will get marshaled into JSON and sent back to Alexa. It's like that easy, which is really cool. So yeah, you already saw me test it. This interface is really great because if you're developing it, you can see the input, you can see the output. It just couldn't be easier to develop. And so Golang and Lambda, no problem at all. The next steps for me in my project is I have a temperature sensor in my office. that sends its data up to an MQTT server. So I'm actually going to modify this code to include a call out to the MQTT server to get the actual temperature and return it. But otherwise, you can see sort of how it works. So that is soup to nuts, sort of a quick walkthrough of Alexa skills development in Golang using Lambda. So I hope it's of help. I'm sure there's a bunch of bits here that I haven't covered, but hopefully it's enough to sort of show you at least that it does work and give you a little encouragement as to sort of how to go about it. So good luck.